So you might have heard the news that mankind has reached out beyond the solar system. But what does that actually mean, and how big is the solar system anyway? Defining the size of the solar system isn't as easy as it sounds, because there's lots of ways you can do it. All of them, though, have the sun at its heart. So surely the size of the solar system is just the region of space that the sun has influence over. Whilst that's correct, there's lots of ways you can define influence. Let's start with the one that's been in the news with Voyager 1. By the way, if you want to check out a video of me talking to a real-life astronaut, why don't click there. The movies claim that in space, no one can hear you scream, which you might think is because space is empty, right? Except it isn't. Space is actually filled with plasma, charged particles, and magnetic fields. These blow out from the sun as the solar wind because its gravity isn't enough to keep a hold of it. Now, the solar wind is nothing like the gusts that you and I complain about on Earth. It's only got 5 particles within the volume of, say, a sugar cube, compared to the 27 quintillion, that's with 18 zeros on the end, that you and I breathe here in Earth's atmosphere. The solar wind blows at about 500,000 miles an hour to 2 million miles an hour. That's actually supersonic within that plasma. But as you get further away from the sun, it starts to slow down. The 2 Voyager spacecraft have been measuring this solar wind on their journey, which started all the way back in 1977 when they both launched. The original mission was planned as a grand tour of the outer solar system, passing by Saturn, Jupiter, Uranus and Neptune. But by the late 80s, they'd already done all that, so they continued on into the unknown, so to speak. In terms of the influence of the sun's particles and magnetic fields, you know, the solar wind, then the heliopause is the edge of the solar system. This is where the solar wind is slowed right down by the interstellar medium, the stuff that's in between the stars. Now, since May 2012, Voyager 1 has been in the news reporting that it has crossed this boundary at some distances of about 121 to 125 astronomical units. Now, an astronomical unit, by the way, is the average distance between the Sun and the Earth, about 93 million miles. We don't actually know for sure, though, whether Voyager 1 has crossed into interstellar space. It's all brand new, even for us scientists. What we do know, though, is that Voyager 1 has seen an increased number in cosmic rays, a decreasing number of solar wind particles, and slight changes in the magnetic field. But the debate is still open whether it has crossed the heliopause. But how else could we define the edge of the solar system? Well, of course, there's gravity. The gravitational force in theory is infinite in range, but in practice there's so much other stuff out there in space, like stars, galaxies, etc., that after a certain distance of the sun, the gravitational force should be negligible due to the sun's influence. So what number is that? Well, it turns out that's quite hard to work out as well. One way is to ask whether gravitational force to the sun is equal to that of our galaxy, the Milky Way. This is called the Gravitational Sphere, and it works out to be 4,500 AU. But then again, there's the Oort cloud, which is a much further distance away, where we think all of the long-period comets come from. So there's the sphere of activity. This is the region where it's feasible for a planet to orbit around the sun rather than the galactic core. This works out at 60,000 AU. That's almost a light year. Then again, there's the Hill sphere, which is the theoretical limit at which a satellite could orbit around the sun. That works out at 230,000 AU, except that's almost the distance to Alpha Centauri. So which one of those numbers in terms of gravity is right? The final way that you could gauge the size of the solar system is with light. And I can give you an upper limit for that value. The sun currently is about 4.6 billion years old, which means that very first light it emitted when it became a star has travelled 4.6 billion light years, though right now it's probably extremely faint. So that would be the size of the influence of the sun's light. Back to the original question then. How big is the solar system? Well, it's between 120 AU and 4.6 billion light years, depending on which definition you like. For a bit of extra space-related head squeeziness, why not check out where extraterrestrials might be here, or you can check out my favourite head squeeze videos here.